Our fourth practice problem for grade 11 Euclidean geometry. We have an 8.2 that says in the diagram below, ABC and E are points on the circumference of a circle. BC produced meets AE produced at point D. Remember what it means if two lines are produced, it just means that they are extended. So when AE is extended, it's actually extended to D. And when BC is extended, it's actually extended to D. So they both meet each other at point D. Okay, that's just what they mean. It says AB is equal to AC. So here is AB, here is AC. And if those two lines are equal to each other, I want you to notice that triangle ABC is now an isosceles triangle. They then mentioned that angle D is 35 degrees. Here's angle D. Angle A1 is 40 degrees. So both of those are indicated on the diagram. Now 8.2.1 says determine with reasons, and we need to get angle C1. So here is where angle C1 is situated. And like I've just mentioned, you need to notice that triangle ABC is an isosceles triangle. What it means if the triangle is an isosceles triangle, it means that these corner angles are equal to each other. Now this is quite easy for us to work out since we already know angle A or A1 in this triangle is 40 degrees. So to get angle C, all we have to say is angle C1 would be 180 degrees minus 40 degrees divided by 2. And this is how you always calculate it. When it comes to getting one of the angles that are equal to each other, you say 180 minus the third angle and divide by 2. So this is going to be equal angles, opposite, equal sides. That leaves you with angle C1 being 70 degrees. Okay, so on our diagram, we can fill that in. But remember, it's those two corners that are 70 degrees. Next, we need to calculate angle A2. So here is where angle A2 is situated. And just by analyzing this diagram, if we knew what B2 is, we could use angles in the same segment. But since we don't know B2 on its own, we cannot use angles in the same segment. Instead, we need to check for another way in which we can get A2. And here's what I notice. I want you to focus on the entire big triangle, triangle ABD. And I need you to notice that in this triangle, you have two corners. In fact, you have part of the third corner. If you look at angle A, you know A1 is 40 degrees. So what we can do is, we can minus all of these angles from 180, and we'll be left with A2. We can say angle A2 is equal to 180 minus 35 minus 70 minus 40, and we'll be left with A2. So let's write that down. So we have angle A2 is 180 minus 35 degrees minus 70 degrees minus 40 degrees. That was the sum of the interior angles of a triangle. And that leaves you with angle A2 being equal to 35 degrees. Okay, we now need to calculate angle B2. And as I mentioned before, if you guys look at angle A2, you'll notice that A2 is subtended by points E and C. E and C also subtend to B2. So what this means is that angle B2 and angle A2 are equal to each other because they are angles in the same segment. So angle B2 is equal to 35 degrees. Now for 8.2.2, it says, hence, prove that BE bisects angle ABC. Here's the thing about questions in maths that say hence. Now you guys should already know this. Whenever a question says hence, it means using your previous answer. And our previous answer was B2. So we need to see, how can we use B2 to show that this line BE is going to bisect angle ABC. Now what does that mean? When a line is bisected, or when an angle is bisected, it is cut into two equal parts. It's cut in half. Basically here, we need to show that angle B1 and angle B2 are equal to each other. Now we can already see that angle B2 is 35 degrees. So what we can do to get angle B1, to show that angle B1 is 35 degrees as well, is we can take the 70 and minus 35. And it will give you B1 as 35 degrees. Which makes sense, right? We can take the 70 minus 35 and we get B1 as 35 degrees as well. Let's write that down. So I'm just going to show how I'm getting this 70 minus 35 to show that, okay, B1 is equal to 35 degrees. So angle B1 is equal to angle B2. And if you'd like, you can mention that B2 is 35 and you can say proven. So if you want to mention that, you can say that, okay, angle B2 is also 35 degrees. That was proven already. And since the two angles are equal to each other, then yes, it means that the whole angle ABC has been bisected. So we can now conclude and say, therefore, BE bisects angle ABC. Please remember to like, subscribe, and turn on your notifications for more content.